Good morning, children. Today we are going to study about uniform circular motion. Before going to uniform circular motion, let's study what is circular motion. What exactly is motion? When an object moves from one place to other place, or when an object travels some distance with respect to a reference point, you call it as motion. So what is circular motion? When an object moves in a circle, it is called circular motion. Example, an athlete taking a round of a circular path. Look at this athlete here. He's moving in a circular path because this track is in the shape of circle. Athlete is taking a round of a circular path. So you can say athlete here is in circular motion. So now we are going to study what is uniform circular motion. If an object moves in circular path, yes, if an object moves in circular path at uniform speed. So he's moving in circular path that too at uniform speed. What is uniform speed? When an object covers equal distances in equal intervals of time, then you say it has uniform speed. So if an object moves in circular path at uniform speed, it is called uniform circular motion. It has to move in circular path and it has to move with uniform speed. Then only you call it as uniform circular motion. Examples: motion of moon moving around the earth. If you observe here, moon is moving around the earth. Yes, so moon is moving in a circular path around the earth. So we can say here that moon is in circular motion. In the same way, if you observe here, Earth is moving in a circular path around the sun. It is moving in a circle around the sun. So now we can say that Earth is in circular motion around the sun. Yes, and we can also say they are in uniform circular motion also, because moon is moving around the Earth in circular motion, that too it will be moving with uniform speed. Even Earth will be rotating and revolving around the sun in a circular path, and it has a uniform speed. It has a uniform speed. So we can say this is the perfect examples for the uniform circular motion. Now let's take second example, a cyclist moving on a circular track. Yes, when a cyclist is moving on a circular track, look here. If you observe the track here, it is in the shape of a circle. So the cyclist will move in this circular path taking. Yes, will move in this circular path. He has many turnings and ultimately he will come back to the original position. If the cyclist is moving with uniform speed, if he is moving with uniform speed, then you call his motion as uniform circular motion, because he is traveling with uniform speed and he has been moving in the circular direction. We call this as an example for uniform circular motion. Next concept, what is constant in uniform circular motion? So what is constant? Which does not change in the process of uniform circular motion. First one, speed is constant. Yes, when you say in uniform circular motion, always speed is constant. As I said, the body will be covering equal distances in equal intervals of time. So we can say speed is constant. As our object keeps on changing direction, velocity keeps on changing. Now, speed is a constant. Speed is a scalar quantity. It has only magnitude but no direction. So when you are talking about speed, you are only worried about the magnitude. How much distance the object has covered, you are only worried about that. But when you're talking about velocity, we are worried about the distance covered in that particular time, and we are also concerned about the change of direction by the body. If it is changing direction means even though the magnitude is same, velocity keeps on changing. Yes, its value velocity numerically might be same as speed here, but that as velocity is a vector quantity, you have to consider both magnitude and direction. Even though if the magnitude is same, yes, same as speed, we cannot consider it has, yes, we cannot consider it has uniform velocity because direction is keeping on changing continuously. So we can clearly say that velocity cannot be, yes, velocity cannot be constant in uniform circular motion. Speed is constant. So what is constant in uniform circular motion? Speed is constant, but velocity is not constant in uniform circular motion. Very important point. Yes, so now we have to think why is the body, why is a, yes, why does a body which is moving in circular motion is not maintaining a constant velocity? Yes, why is the velocity not constant when a body is moving in a circular path? Let's look at the explanation for this point. Now let's take different tracks. Let's take different tracks. Let's take a rectangular track. If an athlete travels, yes, travels rectangular track A, B, C, D, he has to change direction 4 times. Yes, because there are 4 corners, he has to change the direction 4 times. Okay, because it has 4 edges, he has to change the direction 4 times so that he can reach the other end. Yes. What are the 4 sides? A, B, B, C, C, D, D. He has to travel on A, B, C, C, D, and D. So he will change the direction 4 times when an athlete is moving on a rectangular track. Next, look at the hexagonal. What do you mean by hexagonal? Hexa is 6. So when I tell it is a hexagonal track, it means that it has 6 edges. So similarly, when an athlete is moving in a hexagonal track, when he is moving in a hexagonal track A, B, C, D, E, F, athlete has to change his direction 6 times. Yes, how many times he has to change once? For example, imagine if he starts from here. Yes, here he has to change the direction. At C he has to change the direction. At D he has to change the direction. At E, at F. So overall he is changing the direction 6 times. Let's see the next track, octagonal track. As the name suggests, octa means 8. When I say octagonal track, it has 8 edges. So when an athlete is running on an octagonal track, he has to change his direction 8 times. Look here, if he starts at A, he has to change direction at B, C, D, E, F, G, and H. So he has to keep on changing the direction 8 times to complete the circular motion. Okay, to complete the octagonal track. Yes, so we have seen rectangular track, hexagonal track, and octagonal track in which athlete has to change direction many times. Now, if you, so when I talk about hexagonal, octagonal, rectangular, you have edges. So if you observe from rectangular to hexagonal track, the edges have been increased. From hexagonal track to octagonal track, also the edges have been increased. We are increasing the number of edges. From the octagonal track, if you keep on increasing the edges, yes, you keep on going increasing the edges, there will be a point at which it forms a circular track. If you keep on increasing the number of edges of an octagonal track, it goes on, goes on, goes on, it goes for a polygon. Yes, many sides, and from there it forms a circle. Yes, and this you call it as a circular track. Yes, if you go on expanding the edges, at one point it will form a perfect circle. So an athlete moving in a circle changes directions indefinite number of times. So when he is moving in a circle, he has to change his direction indefinite number of times. Why is uniform circular motion always called accelerated motion? If a person travels in uniform circular motion, when a person is traveling in uniform circular motion, the magnitude of velocity will remain constant. As I told you, if the speed of your body is 5 meters per second, then the velocity of the body will also be 5 meters per second. But here, yes, velocity, the magnitude of velocity is not changing, but the direction is not remaining constant. However, the direction of motion keeps on changing indefinitely. Yes, when the direction of motion is has kept changing indefinitely, then you cannot say that the velocity is remaining constant. When the velocity is continuously, yes, when the velocity is changing due to the change in direction of the body, you call your uniform motion, or you have to call uniform motion as an accelerated motion, because there is change in velocity due to the direction. Whenever there is change in velocity with respect to time, we have to call that kind of motion as accelerated motion. So uniform circular motion is always called as the accelerated motion. Let's see examples for this. An athlete running in a circular track with uniform speed keeps on changing direction indefinite number of times. If this athlete has to move in this circular track, he has to change directions many times. Imagine a person moving on a road. Yes, straight road. He did not change the direction indefinite number of times. But a person moving on a circular track has to definitely change the direction indefinite number of times, because he has to reach the other end. He has to, yes, he has to take many turnings, or he has to change direction indefinite number of times. Since direction keeps on changing, it is called accelerated motion. A toy train, you would have definitely seen toy train. A toy train moves in a circular path at constant speed. Yes, it will move in a constant, whenever you give key to it, it moves in a circular path at a constant speed. But direction of toy train, the direction will keep on changing indefinite number of times. Even though it is moving at a constant speed on this circular track, the direction of the toy train will keep on changing indefinite number of times. Since the direction, yes, even though it is moving at a constant speed, since the direction is keeping on changing, it is called accelerated motion. How to calculate distance and speed in case of circular motion? How do you calculate? Because a person is moving in uniform circular motion, definitely he or she will cover some distance, and they cover the distance at particular speed. So it is very much necessary to calculate distance and speed in case of circular motion. So if you observe here, point A, the starting point A, yes. So this is the initial point. So the total distance, how can you calculate the total distance traveled here? If the person has to travel along the circle, so he has to move along the circle. He has to move along the complete circle and turn back. So in that case, how can you say, with what can you just calculate, with what formula can you calculate the distance traveled, as it is covering the total circumference of the circle? Yes, the object has to cover the total circumference of the circle. So the total distance traveled can be calculated by using the formula for circumference of the circle. As we already know, circumference of circle is can be calculated by the formula 2 pi r. You can use the same formula to calculate the total distance traveled in case of circular motion. Yes, so total distance traveled can be calculated by 2 pi r, where pi is 22 by 7 or 3.14, and r is the radius of the circle. As you all know, radius is always half of the diameter of the circle. Now we have seen about the distance, how to calculate the distance travel. Yes, now let's see what happens to the displacement. How will the displacement vary? Yes, a person is starting at an initial point A. Yes, he's going along the circumference of a circle and is coming back again, because it is a circle. Because it is a circle, the person will definitely come back to the initial point. Yes, when any object is starting from a point and reaching the same point again, so we can say that the displacement of that particular body is definitely zero. So, when object moving in uniform circular motion, total displacement will always be zero, and the distance traveled can be calculated by using the formula of circumference of circle, which is 2 pi r, where r is the radius of the circle. Now we'll see how to calculate the distance and displacement for semicircle. Now we have seen for circle how are we going to calculate the distance and displacement. Now let's see how are we going to calculate distance and displacement for a semicircle. So in this case, how will you calculate the displacement? If an object is there at point A and it has to reach the point B. Now this part is not there because we are talking only about the semicircle. So if it has to reach from point A to point B, how much it has to cover? Obviously, it will not choose this path because displacement is always the shortest route a body can take to reach to the destination. So if B is its destination, it will try to opt for the shortest route. So it will not go in this way. Yes, it will not go in this way. It will always take the shortest route, which is from A to B, the straight line. So once seen this picture, yes, if you take the center point of O and exactly divide the circle to the center, yes, from A to B, yes, this line will represent the diameter. Yes, half of the diameter is radius. So two sides, this is radius and diameter is divided into two parts. This side R and this side R. So when I talk about displacement, it should be displacement always indicates the diameter of the circle. So how can you represent the diameter of the circle? Radius here plus radius here, R plus R to R. Yes, diameter is always 2r. So if what is the displacement of a semicircle? It's 2r. And what is the distance travel? Now we have seen the displacement. What is the distance travel? If it has to go only in this path, what is the distance travel? As we all know, when it was complete circle, we said distance is the circumference of the circle, which is 2 pi r. Now when it is half circle or semicircle, we have to just divide 2 pi r divided by 2. 2 gets cancelled and we have pi r. So distance traveled by an object in a semicircle can be calculated by using the formula pi r, where r is the radius of the semicircle and and displacement is always 2r. R is the radius of the circle. In this way, you can calculate the distance and displacement of circle and a semicircle. Now look at this question. Look at this question. How can we solve this question? So here what he has given. He has given diameter is equal to 144 centimeters. Yes. Diameter is equal to 140 centimeters. Yes, if diameter is equal to 140 centimeters, then radius is equal to radius is always half of the diameter, so it will be equal to 140 divided by 2. So what is 140 divided by 2? That is equal to 70 centimeters. So now the radius is 70 centimeters. We can calculate the distance covered by the person. As we know, distance is equal to 2 pi r. We simply substitute that 2 into 2 multiplied by what is pi? Pi, as I told you, the value of pi is 22 divided by 7, or you can take it as 3.14. Here I am taking it as 22 divided by 7 is multiplied with r. Yes, multiplied, what is r here? 70. So if you solve it, this should be, yeah. So if you solve it, you get the diameter as 2 into 22 by 7. So if you calculate it, what do you get? 7 times 70. Yes, 2 into 2, 44. So distance covered by the person comes to D 440 meters. Yes, if the diameter of the circle is 140 meters, the total distance covered by the person is 440 meters. So this is how you calculate the distance covered by a person. Now, how do you calculate? How do you calculate velocity? How do you calculate velocity in circular motion? Now let's see how do you calculate velocity in circular motion. Yes, as you all know, velocity is equal to distance or displacement by time. So I'll be just be taking d by t. Okay. So as you already know, distance is equal to 2 pi r by t. So as we already know, pi is 22 by 7. Seven into r, yes, divided by t. So in this way, just 22 pi r divided by t. By using this one, because velocity is equal to distance by time, as we already know, distance is 2 pi r. Just divide that 2 pi r by the time given in the question. Then you can easily get the velocity of that particular body. Now we'll try to solve a numerical. Yes, now we'll solve this numerical. Suppose a person takes a round of circular path whose diameter is 140 meters in 2 minutes. Now he has given a time in which he is covering the diameter of the circle, which is 2 minutes. Calculate the distance covered and the speed of the person. Yes, the distance with this. So we have to calculate the distance covered and also the speed of the person. Let's see how to calculate this. Let's first calculate the distance. Distance is equal to 2 pi r. 2 into 22 divided by 7 multiplied with what is r here? Diameter is 140, so radius is half of that, so 70. So this value comes out to be 440 meters. So now we got the distance. We know that velocity is equal to distance by time. Now when you already know the velocity, so you can, when you want to calculate the velocity and you already know the distance, 440 meters divided by what is the time? 2 minutes. Can we take 2 minutes? No, because minutes is not the SI unit of time. We have to convert minutes into seconds. So 1 minute is 60 seconds. So 2 minutes comes to be 120 seconds. So 440 divided by 120. What is the velocity now? Yes, 0 gets cancelled. 2 6 is a 222s. 2 3 is a 18. So it comes around 3.5 meters per second. So this is the way how you calculate the distance and the velocity of an object moving in a circular path in uniform circular motion. So this is the way how you calculate the numericals for uniform circular motion. If you quickly go to what we have studied today, we have studied what is circular motion, what is uniform circular motion. In uniform circular motion, what is, yes, examples of uniform circular motion: moon moving around the earth, yes, and the earth moving around the sun, a cyclist moving on a circular track, is also an example for uniform circular motion. Next, we have also seen what is constant in uniform circular motion. I told you that speed is constant, but velocity is not constant in uniform circular motion because the object keeps changing its directions continuously. So velocity can never be constant in uniform circular motion. Okay, I have given an explanation taking the rectangular track, hexagonal track, and octagonal track, and why the object has to take many turns in a circular track. Yes, an athlete moving in a circle changes directions indefinite number of times. Why is uniform circular motion always called accelerated motion? We have seen why we are calling uniform circular motion as accelerated motion, because the velocity is not remaining constant. When the velocity is keeps on changing with time, we can say the object is accelerating. That is the reason we are calling uniform circular motion as accelerated motion. We have taken few examples like an athlete running in a circular track and a toy train moving in a circular path. We have seen how to calculate the distance and speed in case of circular motion. We can calculate distance by using formula 2 pi r, and we can calculate. We have also seen how to calculate the distance and displacement when it is half circle or semicircle. We can get distance traveled by a person on a semicircle by using the formula pi r, and the displacement in this case is always equal to 2r. We have also seen one numerical to how to calculate the distance covered by the person when the diameter of the circle is given. We have also seen how to calculate velocity in circular motion, and we have seen numerical in which we have calculated both the distance. By using distance, we have calculated the speed of the person. Yes, hope you all understood. Thank you. Take care.